Guys, welcome back to Consistent Code. So today's problem of the day is minimum cost of ropes. So basically what this problem says that you're given four ropes, or you are given an input n that denotes how many ropes you are given. For example, in this case, you are given four ropes. And now this array contains the length of each rope that you are given. So we are given four ropes of length 4, 3, 2, and 6. Now what we need to find the minimum cost to join all of these ropes into one single rope. So and what will be the cost of joining any two ropes? For example, if I'm joining two ropes of 4 and of length 4 and 3, then the cost to join these two ropes will be the sum of their lengths. So if I join the ropes of length 4 and 3, the cost to join them will be 4 plus 3, that is 7. And if I join the ropes 3 and 2, my cost will be 3 plus 2, 5. Similarly, if I join 3 and 6, my cost will be 3 plus 6, that is a 9. How to approach this problem? Since we want the minimum cost, right? So suppose we are given this case, and since we want the minimum cost, so first of all, we should join those two ropes which are having the minimum length so that we have the minimum cost. So we will be joining first 3 and 2. Now, and let me say the cost initially is 0. Now, when soon as I join these 3 and 2, I will have, I was having 4 ropes. Now, since I joined 3 and 2, I will be having 3 ropes of length 4, 5, and 6. And my cost has become 3 plus 2, that is 5. Now, because we want minimum cost, so we will be joining the two ropes having the minimum length first. So now we can see the minimum length are 4 and 5. So we can join 4 and 5 and make the length 9 and 6. So the cost now will become 9 plus 5, and it's 14. Similarly, now we can join these two rows and the cost will become 15. Sorry, total length will become 15 in the end. And my cost becomes 14 plus 15, that is 29. And this 29 will obviously be the minimum cost, because what we have done, we have taken the minimum ropes at first and joined them. If we will take a larger rope, then our cost will definitely increase. So how to code this stuff now? So as you can see, since we are taking the minimum elements every time, so the data structure which should come into your mind should be heap data structure, or since we are using C++ here, so I can say priority queue. And in fact, uh, minimum priority queue, right? So now let's code this problem. So first of all, we need to create a priority queue. And also we need to take care of this thing that everything has been given in long long. So we should take everything in long long only and not consider to take everything in int. So let's create a priority queue of type long long. And since we want a minimum priority queue, so let's say this is a minimum priority queue because we want to extract the minimum element every time. So this will be vector of log log. This is a general syntax. If we want a minimum priority queue, and then a greater long log. And let's name this priority queue as PC. So this becomes our priority queue. And what will we be doing now? Because we need the minimum elements every time. So first of all, we need to push all the elements in the priority queue. So we will push all elements in PQ at first. So I can say for long long I equals to 0, I less than n, and I increment it. And what we need to do, we need to just push these elements. PQ dot push ARI, and that's it. All right. Now we need to extract the minimum elements. But until when? Till we do not have only one element left. Or we can say the size of priority queue does not become uh, less than one, or it becomes one. So we can just put a condition while PQ or size is greater than one. We will be extracting the two elements and adding it to our cost. And also let's initialize our cost as zero initially. And now what we will do, we need to extract the two minimum elements every time, right? So let's call the first minimum element as A. That should be our PQ dot top. And then we will be popping this element from our priority queue. And now we will be extracting the second element, the second minimum element from a priority queue. And let's call that element as P. And then we will be popping this second element from the priority queue. And then we need to add, push the element which is having the length, which is the sum of A and B. So we will simply push PQ dot push A and B. And also we will be incrementing our cost by A plus B. And that should do the job. And this loop will be running until we do not have a single element left in our priority queue. And we have added all the cost for the minimum element every time which we get. So finally, we can simply return the cost. And now let's try compiling and running our code and check if this is working fine. And if it is working fine and it is working right, so now let's submit this code. Okay, so there is one error here. Okay, we should mark these A and B also as long because A and B, as you can see initially, and the array is given in long. So if you're taking the minimum elements from the array, these will be the sum of, like if you took 2 and 3, that its sum is 5. So next time you are taking the minimum as 5 and 4. So you need to take A and B as long also. So now let's submit this again. And we solved the problem successfully. And I hope you liked the explanation. And if you did so, make sure you like the video and subscribe to the channel for more of such content, as it motivates me to make more of such content. And I'll see you next time with the next problem of the day.